Good morning, everybody. We'll begin today's session. The first question. Water is kept in 4 identical beakers, but made up of 4 different materials. One is shiny tin, one is matte black tin, one is shiny stainless steel, and other is a blue-colored plastic. When kept under the sun with the same amount of water and for the same amount of time, water in which of the beakers will be the hottest? Okay. Shiny tin beakers, shiny stainless steel beaker, blue-colored plastic beaker, or matte black tin beaker. Here we'll go with the option D, which is the matte black tin beaker, because black is the color which absorbs heat. And yeah, the answer is option D. We'll move to the next one. Shown below is a one-point perspective drawing where all the blocks except one share the same converging point, identifying the block. You have to identify that block, which is that one block which does not follow that same one-point converging point, which is a part of one-point perspective. So here it's pretty simple. It is the block C, because in this case, in case of C, all the edges are parallel to each other. They do not converge at one point. Okay, we'll move to the next one. Below is a set of pictures that show variety of domes used in Islamic architecture in India. Select the order in which the design of the domes were developed from 13th to the 18th century BC. Okay. So in this case, if you're not aware with the history of Islamic architecture and how the design of the domes have evolved, it will be better if you stick to what is given in the option. From the options, one can see that second or third are the first one. In this case, the obvious is obviously this dome came first, which is a number 3. So it eliminates option A and D. Between B and C, it's after 3, it's either 1 or 2. Actually, it is option 2. The second one came earlier than the first one. So 2, and then followed by 2 will be 1, and then followed by 1, 4, and then the last one, evolved design, is 5th. The correct answer is option C here. We'll move to the next one. Shown below are 2 views of a same 3D object. How many non-contiguous surfaces are there in the object? Okay. Basically, how many surfaces? We have to count the total number of surfaces here. Okay. So in this case, if I study the object carefully, I will observe that this part, and this part is identical. It's the same, but it gets repeated 3 times. So how many surfaces are there in these parts which are not shared? So when I see the back side of it, this is a shared surface between 2 parts. So I won't count the shared surfaces. I will count the surfaces that are not shared. Okay. The surfaces that are not shared are 1, 2, 3, 4, 5, 6. And then ये नीचे वाला जो आपका surface है will be the 7th surface. And along with that, this one, which is left out, will be the 8th surface. So there are 8 surfaces that are shared, that are there in all the 3 parts. There are 3 parts, so it will be total 24. Besides this, I'm still yet to count other surfaces. These 3 surfaces, and these 3 surfaces. So 3 into 3, which is 9 surfaces. In addition to that, there are the shared surfaces which are left between the parts. So 1, 2, and 3, plus 3. This adds up to a total of 36 surfaces, which is the total number of non-contiguous surfaces that this object has. We'll move to the next one. Sharmila takes the office bus home every day in the evening. She takes the 5 o'clock bus and gets off at 6 o'clock at the bus stop near her house. Her husband, driving from her home, picks her up at the bus stop and then drives back home. One day, Sharmila decides to take the 4 o'clock bus and reach her bus stop at 5 o'clock. Thinking that her husband won't be able to pick her up earlier than usual, she decided to walk home. At some point at some point during her walk, her husband picked her up and they reached home 10 minutes earlier than they usually reach home. Assuming that Sharmila's husband always drives at constant speed and that on this occasion he left home as usual, how many long minutes did Sharmila had to walk before she was picked up? Okay. In this case, we'll write it down very clearly. First, This is her office. This is the bus stop. And then there is a home. Okay. This is the usual case scenario. She takes the 5 o'clock bus, gets off at 6 o'clock at the bus stop. Sharmila from the office takes the from the office takes the 5 o'clock bus, gets off at the bus stop at 6 o'clock. Her husband driving from her driving from her home, picks her up at the bus stop and then drives back home. At 6 o'clock, the husband picks her up and then drives back home. So this is the husband's movement. She goes here, the husband goes here and then picks her up and comes back. This is the usual time. Now, in another scenario where she leaves office at 4 p.m. Here she leaves at 4 p.m., reaches the bus stop at 5 p.m. and from here she starts walking. And at one point in time, this is one spot where the husband picks her up. Okay? Sorry. Let me just write Sharmila's moment like this. The red is Sharmila's moment. She's walking. And then from here, the husband goes, picks up Sharmila and then comes back home. When he comes back, they are actually 10 minutes early. Okay. In this case, how long did Sharmila walk is what we have to find. So time saved here, which is 10 minutes, is equal to the husband going and then coming back. So if I take the going and the coming back as one module of x plus x, 2x is 10, so x will be 5 minutes, which means the husband took 5 minutes to reach this spot and then come 5 minutes to come back, okay, home. Now, in this process, from their usual time, which may be 7, 8 or whatever, the husband took her up, so within that 1 hour or 60 minutes, which may be the time frame that they would have been usually reaching back, usme se 5 minutes are gone. Okay, they are there for 10 minutes early, so 5 minutes is the time frame where she reaches. So, if she starts at 5 o'clock, 5 minutes are the one, so usme se 55 minutes are the one which would have been spent on walking, and then 5 minutes the husband takes to reach her, and then 5 minutes for them to come back. That's how 10 minutes gets saved. So ideally, she should be walking for 55 minutes. Okay, we'll move to the next one. A 3x3 grid is shown as a figure A to be filled with numbers 1 to 9 according to these rows, all these rows. Okay. What is the sum of the 3 numbers in the middle row? Middle row के 3 numbers का total sum is what we have to find. Let's look at the conditions. Okay, 8 is above 9 and to the right of 8 is above 9. So 8 is above 9 and to the right of 2. Okay, 3 is to the right of 7 and above 9. 3 is above 9, so 3 can come here, and 3 is also to the right of 7, and 9 which is to the left of 4. Okay, 2 is to the left of 5. So here 7 is above 6 and 2. 7 is above 6, so ये 2 है तो 6 यहाँ पे आएगा. 1 is above 5, so 1 यहाँ पे आएगा. And yeah, to the left of or to the right of means in the same row, and above or below means in the same column. Okay, so this is how the condition will be: 7, 3, 1, 2, 8, 5, 6, 9, 4. The addition of numbers in the middle row will be 15. Okay, we'll move to the next one. Figure 1 shows an unfolded view of a box, which is this one. The dotted lines depicts the folding lines. The option shows 4 fully folded boxes. You have to identify the boxes that can be unfolded as figure 1. Okay? One or more options are correct. In this case, when you look at the options, B and C are peculiar options because they have the three colors, brown, green, and blue, sharing that one corner. There is no possibility in any of these places. So yes, the brown and blue do come together like this, like we are seeing here and here. But the green here is not in this position. If the green was in this position, it would have been correct. But it's not the case. So B and C are wrong. A वाला जो option है where brown and green come together in one straight line, that actually happens here when this and this edge they come together. And then of course one top edge of blue will come here, so A is fine. Again, brown and blue are coming together. The place where brown and blue, they are in alignment with each other. We have already seen it that happen here and here. And then the green part, which is this one, fits in together. So D is also fine. So correct answer is A and D. Okay, we'll move to the next one. When force is applied on arms P and Q in the direction indicated by the arrows, R and S move away from each other. When I apply force in this direction, R and S, they move apart from each other. And when that force is removed, R and S, they fall back in the same position, which means they come down. Which of the options satisfies this condition? In this case, if it is A or C, which are practically similar, in that case, when force is applied, they will actually move towards each other. B and D are the ones where they will be apart. So B and D are the right answers here. Okay, we'll move to the next one. Which of the options given below can fit in the empty box? Which of these options can fit in the empty box? Okay. So in this case, we'll count the circles and triangles because the geometry is not adding or anything. So we'll just count the first we'll count the circles and triangles. So here there are 3 circles. So here there are 3 circles and 3 triangles. In this case, there are 2 circles and 4 triangles. In this case, there are 5 triangles and there is a 1 circle. Now, next one, we have 4 circles and we have 2 triangles. We have 3 triangles and we have 3 circles, and we have 2 circles and we have 4 triangles, which means the triangle is increasing when I go from top to bottom, the circle is reducing. So here in the final figure, we have 1, 2, 3, 4 and 5. 5 circles and 1 triangle. Next, we have 4 circles and 2 triangles, and then we will have 3 circles and 3 triangles. So where exactly is that happening? Option A has 3 circles and 3 triangles. B has 2 circles and 2 triangles. C has 3 circles and 3 triangles. Option D has 4 triangles and 3 circles. So D is wrong, B is also wrong, A and C are the right answers. We'll move to the next one. 3 positions X, Y, and Z are marked on the cutting edges of a pair of scissors as shown. Rank the points in terms of cutting strength from strongest to the weakest. Okay, the strongest cutting point to the weakest cutting point. In this case, the strongest cutting point will be X and the weakest will be Z. So answer is A, which says X, Y, and Z. Okay, we'll move to the next one. Shown below is a map of a city with names of prominent localities. A man starts walking from Hampalkate towards the west. This is Hampalkate. Takes the second right, second left, first left, third right, second left, and walks on straight to the end of the street. Where does this person reach? Where does he reach? Okay, so let's follow the direction. In this case, this is north, south, west, and east. Okay, This guy is walking towards the west. So from Hampalkatte, he moves towards the west. He takes the second right. From here, this is the first right. This is the second right. This is the turning. From this position, he takes the second left. This is the first left and the second left. From here, the first left. After first left, third right. So 1, 2 and 3. थर्ड राइट यहाँ पे आएगा. थर्ड राइट के बाद सेकेंड लेफ्ट. सो फर्स्ट लेफ्ट and then the second left here. Okay. And after that, he walks straight to the end of the street, which is where he will reach at Kandivali. So option A is the one, which is the right answer. Okay. With this, I will end today's session here. Thank you so much for your time. Thank you, guys.